When you talk about the hydrogen atom, you can solve the equation, the quantum mechanical equation, and you get a full expansion in what they call spherical harmonics. So that's the orbital. So when you say, well, that's my solution to the problem, so it's a probability that electron is somewhere in that region. So that's one of the things, that it's possible to get the solution for the hydrogen atom, It's a very long, expansion in spherical harmonics. And one of the components you're drawing, is the most probable state, right? That's why you're doing a 30.45 energy state, right? All right, that's one thing. But the other thing is the trajectories. You can never see a trajectory in quantum mechanics because that violates the Heisenberg principle.
Yes.
So you cannot say that the electron is right here in this position and you cannot see a trajectory. What you can see is the cloud.
Yeah, that's what we're trying to.
Yeah, you were showing sort of at the end of all you can see a cloud of that's what most of the chemistry books are showing the cloud. But then there is a probability that the electron is here, not too far from the nucleus. But the other important thing is that in the center is a charge.
Yes.
So when you solve the problem, like a dynamical problem is similar to the Newton equation, which is the quantum mechanical equation. So what is the potential between the electron and the nucleus? Is a 1, right? The charge is 1, and the electron has 1. So what is the interatomic potential? Is 1 over r. So if the electron goes to the center, so the potential is infinity, right? So that's what Drew was showing that since the problem is not possible to go very close to the center of where you're solving your problem, because your center, your inertial, your frame of reference is the center. So all your distance are, but you're doing the air, the circling around the sun. It's very similar kind of problem, but the force is different. So this time is electric. So I think you probably need to consider to take the full solution, and individual terms. So you only have to take one term, right? That's why you did the integration on r cube or all of that exponential to r. So that's pretty good.
Thank you.
Yes. Roughly how much code was there? And you said you did obviously quite a bit of coding, but what was kind of the division of labor between the two of you?
Well, see, I did a lot of the coding near the end. Kate definitely helped out throughout the year.
Yeah, I did a lot of research, and then I would help with the coding.
Yeah, we'd get together and we'd go over the coding together. I think I'm a little more.
Yeah, she definitely has more skills with the code, but
You probably said this button didn't work or whatever.
Yeah, she'd type up a bunch of code, and I'd come over and I'd, look, and she'd say,
the mistakes together.
Yeah,
we figure out what went wrong and do the math because.
Is a lot of the framework already there for you guys for getting your graphical framework?
Some of the framework was there. We actually had to implement a lot of our own. For instance, our Sophia is actually not a full. It's not actually, we didn't use any properties of a circle. It's actually tons of triangles put together. And I think there was probably about 3,000 triangles total on that, maybe, something like that. And it was basically, we actually did that in a different format and then implemented that into our code so we didn't have to waste time or waste the update to slow down the program.
XNA doesn't have draw sphere?
No, not that we could find. It might. We just might not have been able to discover it, but we couldn't find it there.
Probably in the utility library.
I want to
what doesn't kill us makes us tough.
I want to get your reaction to this. You use the X and A library, which is for games. At one point you said S and F just slow down and speed up the game time.
Yes.
So you're doing, this is a computer game. I'm wondering if we want to reach students your age and students in your dad's class, if we have to present, if it's a good idea to present science and engineering and math, it's computer games.
Well, I do not think it is the only method. I do think it is I think it can be used very well, but I do not think it should be the only method by any means.
We're not trying to use this to, be the sole source of teaching the atomic. We want it as a teaching aid, a teaching
Well, and it
supplement.
certainly has that effect, and because it does have a kind of game aspect to it, I think it feels like.
That's kind of part of my question, like how much of your code is the model? And how much of your code is making it move, putting it on the screen? Like for example,
You guys can just show us really quick.
if you look at your typical code,
Okay.
there's a ton of junk that doesn't do anything except set up actions.
See if I can. So you want me to look at the code if I can find it, or?
Yeah.
Yeah, it's not too.
I mean, the X&A makes it really high level, so you don't have to really work that hard to make it happen.
Well, I mean, the nice thing about X&A, it pretty much will run it. It already has that framework run out, like it'll just go to the screen. What we had to do is get the electron, get the proton in there, get them to rotate properly, all of that.
And you just let it run. You just change its location.
Yes.
I'm not quite sure actually where my code is. I'm not sure I have it on this computer because I did it mostly at home. Sorry. I'm
Do you
looking.
have some of it in the...
Oh, I don't think some in the final report, but we have some on the poster there. I'm
We
sorry.
have some on the poster.
But I actually think I have it on my other computer. I didn't bring it all here.
Just like, you spent 100 lines, 3,000 lines.
I think it's around there. I'm not quite sure how many lines in particular, but I think it was actually split half-half between trying to get the actual graphics and the electron to orbit properly, and then like half of it doing the math and like the matrices and the probability code. But sorry, I can't say that for sure.
The random number generator, was that something that was provided by the language, or did you have to go and find one? Or
There is a random number generator provided that we did use. It was just, I think, the basic C# one. And we did make a couple variations to it, as in, depending on what we were working with like angles, we had a random number there going from 0 to 1. We would scale it in order to fit with whatever we were doing with it.
Right.
And
Did you just use it when you look at the skewedness, the kurtosis, or any of the aspects of random numbers? You just
No, we
There it
just...
is.
there it is. Use it.
well, it would work. Like when we tried it, it worked. So we didn't want to fix something
But
that
you don't know
wasn't
how bad
broken.
it is as a random number generator.
Yeah.
You're just using what's there. What grade are you using?
We're seniors.
Maybe I have time to leave one more question. Good. Okay. Thank you, ladies.
Thank you.